Hello, everyone, and welcome to Generative AI in Kubernetes Era with Kubeflow. So, yeah, talk of the town. My name is Saiyam Pathak, and I'm a field CTO at Civo, and I'm a CNCF ambassador doing a bunch of cloud native things. Yes, I'm from the cloud native background, not the machine learning background. So, I'll be sharing all the stuff that I have been learning with you. So, it'll not go. This session will not be super intense in terms of the AI and what the core is, but a high level overview of what things are, where we stand, and how in the Kubernetes ecosystem and some of the tooling that I'll be showing, things become easier when you talk about generative AI. So let's get started. So first, yes, machine learning is everywhere. So take any of your day-to-day activities that you do. I mean, they are more than this, but some of these are here. So it is like AI is everywhere in our lives, wherever we go, whatever we consume, all the content we consume, anything we book online, anything we are hearing, consuming from music, Spotify, so all the recommendation systems. So these are there already, knowingly, unknowingly, interestingly. If you are not interested in AI, wherever you are using it in some way or the other. So why this Gen AI movement? Like why suddenly it has, popped up and everyone like kind of has to learn something about the AI is because of ChatGPT. So it actually skyrocketed the advancements, not the advancements, but skyrocketed the usage and showed a lot of power and potential, like what it can actually do. So that's why everyone is excited. But if you talk about the GPT-2 model, the research community was excited then, because when GPT-2 came out, research community was very much excited. Okay, these are the capabilities that it can. And when they launched the ChatGPT, so the end users got very excited. Okay, I can just ask ChatGPT anything and it will respond me. I know it responds true, false a lot of times. And you can't get everything. Like if you want, give me an application code, it won't work as is. You still have to do your work, so your jobs are not going anywhere. But it has a lot of potential. It does a lot of work, and that's why the overall hype and the Gen AI movement is there. And it's good. Like everybody's taking interest. Like everyone wants to know what this is. I'll talk about some of the models which are decades old. So these are not new. Decades old models have been there. So it's not something that has come overnight, and ChatGPT has come overnight and it has suddenly boomed. So it's years of work that has gone since the foundational models that has come. But it's good that everyone is taking interest. Everyone wants to know what it is, what are some of the use cases, application, how you want to use it. Companies coming in and they want to use and create solutions for the end users to make even their lives better with providing better customer experience, chat support, whatever that is. So very simple. It is just you ask the question and you get the response, and you feel that there is a huge brain outside that knows everything from the internet, and it'll give you a very concrete, concise, and good answer. And you can customize a lot of things that you want the explanation, you don't want the explanation. It understands, like you are chatting with someone, and it understands you, your perspective, and it understands the world, all the books, everything out there, all the public information out there on the internet. So, which is cool. But before that, let's try to understand like very simple, high-level terms. Like these are not the official definitions, but these are just from the understanding that I have learned. The machine learning, so we should be able to understand what machine learning is, what AI is, then we move towards the Gen AI. Some of the basic concepts, let's get that sorted first. So AI is basically, think of it as you are creating something very intelligent, like intelligent systems, and that can reason, learn, and can show the human-like capabilities. So you are talking to a human, the brain that I showed in the last slide. So that is the AI. So all the applications that are around are kind of the AI ones that you see. Machine learning is kind of comes as you can call subset of AI that trains the model, like you give the input, it trains the model, and then it does prediction on the trained data. And that can be done in different forms. Like you have the basic ones are, we'll keep everything to the basics, not going into the deep. So unsupervised learning and supervised. So supervised means you have a data that can be labeled. So you can add tags, metadata, all this information to that particular sort of data. And unsupervised means untagged data. So in this, you try to uh, configure them, like try to make clusters and find out the similarities between the data, like different patterns, different similarities, and you cannot tag them directly. And in supervised, it learns from the past examples. So whatever you give, it learns from that data, whatever the tag data is, and then based on that data, it tries to give you the output. Examples, very common, and you already know these examples, is the spam emails. So the problem statement is filtering out the spam emails. Very simple. So what you'll do, you'll be training the data on all the data set and tag it whether this is spam or not spam based on email IDs, based on authors, based on different parameters. And the model then should be able to predict that the email is spam or not spam based on whatever inputs and structured data that you have provided. For the unsupervised learning comes the recommendations. For example, what people buy and recommend based on that. So, for example, there's a group of customers together. So in this, you will be grouping the customer together based on their purchase, based on the frequency, based on the spend using some of the clustering algorithms. For example, you went into the Walmart store and you have purchased chocolates, and so it try to cluster you with the other users who have purchased chocolates, and then what they buy will be shown to you as the recommendation that you can buy. You might be interested in these, and then you can run marketing campaigns on it, some of like discounts on it that will interest specifically you. So you are being clustered in the user based on what you do, what you spend, all these things. So that's a common thing that you do. So in like you do the input to the model and you get the output, and then it is compared with the trained data, and then it like whatever input you have in the data set that you have provided and whatever the output, if there is a big difference, then it tries to, you have to retrain the model so that the error is minimum. So you have to be the minimum of the error. So that's how it is being done. So we now know on a very high level what machine learning is, and you might be some of the AI experts also are there, but yeah, those who are not, you get a gist of what machine learning is, what AI is. Another thing that is under the subset is deep learning. So it is actually very much inspired, like all the terminology and stuff is also like the brains, how the brain works. Like we have the neurons, so there's the neurons, which is called the nodes. So you have the neural networks that has many layers. So you can see in this GIF as well. So neural network which has many layers, and it is able to then, using these connection points, data points that it has derived into those neural networks and many layers, makes it help to get the complex problems sorted. So that's how it works. It's the human brain like to process data by many connected nodes, and then it is able to make the predictions. And it works on both labeled, unlabeled data. So it works on both, supervised data set and unsupervised. So it works on both the data sets. So that's how it is. Gen AI comes next. So what is generative AI? AI that can create content, that can generate content. Generative AI is generating the content, and content can be in the form of, you have text, you have images, you have videos, you have animations, you have 3D, you have 4D. So all these things are being generated from the input that you give. So it creates the new data points that I was mentioning, and it uses the foundational models. So these are the models that I was talking earlier, that there has been a groundwork over the years with these foundational models, and then it has been improved with the new set of architectures with more and more data, which is there. So with more computing power that has come, and these foundational models, as you can see, the hidden Markov, MCMC, you have variational autoencoders, generative adversarial networks, normalizing flows, and diffusion models that helps you with your image and video generations. And it again works on like you give Yeah, that's the perks, right, for sitting outside. So, so you have supervised, unsupervised, semi-supervised. So supervised gives it some context, like this is how it should be behaving, and then a lot of unsupervised data gives it the ability to predict from whatever you are giving, and giving the output. Gen AI modalities. So generative AI is a big term, and there are a lot of modalities in it. Like you have your text, and in text you have your LLMs, which are the large language model, and you all are using it. I mean, I'm sure you all are using it. So ChatGPT or some of the other ones, or maybe local LLMs, whatever, you might be using it some way or the other. Then you have the image one, which is the diffusion. So it's part of the diffusion models, and the example is DALI. Then the video diffusion one. So you recently saw the OpenAI launching LoRa. So it can create your 1-minute videos. Runway ML was actually doing this already, creating these fancy videos from text. I think it's great, right? For even the content creator community, if you see, people are like surprised, happy, sad, whatever that is, but they are looking into this field. Like this is something in a year, you can see the advancements that have been made in the text to video generation. So that's pretty interesting. Then the 3D, 4D also, you have diffusion and neural rendering. I think 4D and beyond is a pretty interesting space, because that is more tough to get that sort of outputs. But yeah, there are interesting papers out there. Now, like on the basis of, like on the ground level, what machine learning is, what AI is, what generative AI is, why we are hyped up about. So all these things are there, which is good. But now how Kubernetes and cloud native come into the play. So all these companies that you are seeing, like Hugging Face, OpenAI, Bloomberg, NVIDIA, Sun, they have their machine learning workloads running on Kubernetes. And one of the biggest Kubernetes clusters. So this is the statement from OpenAI when they launched a particular blog. We scaled the Kubernetes clusters to 7,500 nodes, producing a scalable infrastructure for large models like GPT-3, CLIP, and DALI, but also for rapid, small-scale interactive research, such as scaling laws for neural language models. Now, this is very interesting, because I think this was not very long ago, but yeah, this was not very new, because ChatGPT 3 was before, obviously, 4, 3.5, and they were using, OpenAI was using Kubernetes, and they also gave a keynote at one of the KubeCons, how they were using Kubernetes. So I think this is pretty interesting, and this also makes a strong foundation why cloud native and a system like Kubernetes will play an important role when you talk about the generative AI and the AI models and the training, inferencing, all these things that you will be doing. So this is where cloud native community is not only excited, they are also working. So there are different foundations. So there is AI Foundation, there's Linux Foundation, AI Foundation, there is CNCF. So all these foundations have to work together so that we can create an ecosystem, we can create platforms, open source platforms that people can use to create more apps using the generative AI models, or local LLMs, or whatever that is. Kubernetes is already working towards it. If you go back and see the KubeCon keynote at Chicago, so Priyanka actually was trying to give a demo on running a Hugging Face LLM on the local laptop, and she also talked about something called dynamic resource allocation. So KEP is a Kubernetes enhancement proposal, and whenever there is something new change that anybody wants to implement inside Kubernetes, the first thing that they have to do is create a KEP. So there are a few KEPs that are targeted specifically for making the machine learning and basically the slicing and dicing of the GPUs. That is more important these days, because you want to use GPUs more effectively, you want to use the infrastructure more effectively, else you will just be using it'll be the same problem like you were in the virtual machines era, that you have single application and your whole virtual machine is there and 80% is wasted. So we don't want to be in that. So that's where the GPU and CPU stuff, however you want to use it, we should be able to slice and dice it in a proper manner. And there is work going on in the Kubernetes community. There is also work going on when you talk about machine learning. Most of the times you will run batch jobs, like heavy batch jobs. So there are products like Volcano that helps you run batch jobs in the Kubernetes cluster. So there's a Kubernetes working group batch that is specifically catering towards the running batch jobs on Kubernetes at scale, effectively, larger batch jobs. So that also contributes towards the AI movement that we are seeing. So just a quick read, the dynamic resource allocation, this introduces a new API to dynamically connect the Kubernetes pod to the network attached and the specialized hardware resources, supporting sharing across the containers or pods, allowing for customer initialization parameters without replacing traditional resource request facilitated by the hardware vendors. The next one is improved multi-NUMA alignment in the topology manager. This is an enhancement to the topology manager that allows it to favor sets of NUMA nodes with a shorter distance between the nodes, making the admission decisions. So these both KEPs, these are just a summary, and these are just from the KEP's own summary. So if you go to the KEP and you see the summary, you'll be able to see the statements over there. But if you want to know the goals, the non-goals, all these things, you can go into the KEP and read through it and also be part of it. Like if you want, if you are in the hardware space, creating new hardwares or software hardwares, howsoever you are doing it, you should be able to contribute over here as well. So Kubernetes is working towards this, and I want to introduce the one such tool, which is Kubeflow, which is very well known in the machine learning ecosystem, in the Kubernetes ecosystem. So Kubeflow started at Google, just like Kubernetes started at Google, and thankfully they open sourced it, and so that we all can play around with Kubeflow. It has matured a lot since they open sourced in 2018, and it is now CNCF incubating project. It became a CNCF incubating project in 2019. As of the latest Kubeflow version, it's 1.8, and it's pretty cool because I think in 1.8, one of the cool features is you can see your volumes in the UI itself. You'll be able to see what all are there, what stuff is there in the PVCs that you are having in the UI, and a lot of features. So I think Kubeflow is growing a lot. And it is also trying, obviously, it also, the community or the members in the Kubeflow community knows how the AI movement is happening, LLM, stable diffusion, all these models are happening. So they are also catering so that these becomes very easy. Another thing which is there, which is not related to Kubeflow, is in the WebAssembly ecosystem is also, a lot involved in the AI inferencing ecosystem. So you can see the companies like Fermion providing AI inferencing using WebAssembly. Then there is LLM Edge, something like that got recently released by Wasm Edge folks, so that you can run local LLMs on your laptops in WebAssembly. So I think these are very interesting times, and the technology also in cloud native, WebAssembly, and everywhere, it's evolving to cater those use cases, and so that you can run everything locally. And there are many benefits, by the way, when you run stuff locally, because you can run unfiltered models, which is one of the biggest thing, because when you run as an application, you are not able to do a lot of things. So you can run unfiltered models. You can train it with your own data that you think it is private, and you do not want your own private information or customer information to go to that specific LLM. So you can use the LLMs locally, and that's why you would use, yeah. It'll come with a circle round. That's what I was told. It should come soon. Yeah, it came. And so what today we'll be doing is, today we'll be using a notebook and Kserve integration. And yeah, Kubeflow is a complete platform. So it's a complete machine learning platform where you can do all the processes in the machine learning ecosystem that you do. And you can also integrate with other open source tools. So it's highly customizable. So it's not only the Kubeflow native things that come, it's highly customizable, and you will be able to add other open source tools like Kflow, Keycloak as authentication, Spark. So all these things can be added to Kubeflow, and people have done it. They have done it, and they have created companies on top of it and selling a Kubeflow with very specialized, highly specialized customizations because it becomes easy for the end users. In the end, it's something is open source, you highly customize it, and you can provide a very good service for a good developer experience and a highly productive machine learning team. Let me just see the time. Okay. So Kubeflow is having, it can do all these things like developing, monitoring, serving, training. So I have less time left, so I'll just quickly walk through the slides because there's a demo as well. Some of the things, it's open source, it's vendor neutral, so you don't have to pay any licensing fees for using Kubeflow. It is Kubernetes native, so you have all those YAML, knowledge that you can use. It's highly portable across cloud providers, so that should be easy, and it's highly scalable because Kubernetes itself is highly scalable. That's the Kubeflow architecture. I mean, you can use all the machine learning tools. You have the Kubeflow pipelines. It can run on any cloud provider. You can see Civo, GCP, any of the cloud providers which is there. And it has its inferencing and very fancy, easy to use UI that you will be able to create Jupyter notebooks, write your code, get it, and using the same inferencing that you create within the Kubeflow cluster. And typically there are this is from the Kubeflow documentation itself. So typically there are two phases that they say is experimental phase and production phase. And in Kubeflow, it looks like this, where you have, for example, you are choosing the machine learning algorithm. So you can use this out of the box. For the experimenting, you can have Jupyter notebooks, you can have RStudio. For the train model, you can have PyTorch, MPI, and the serving also you have your Seldon KF serving, and then hyperparameter tuning, Katib. So all these things are there with Kubeflow that you get. So today we'll be talking about stable diffusion. I just touched on it briefly, generating images from the text. So we'll be writing a text, it generates the image based on the stable diffusion model that are trained progressively. So it denoises the images, and we'll try to show that as well. Okay. So, okay, exit. So that's the Kubeflow dashboard. So if you don't know, at Civo, you have Kubeflow as a service where you can go and create a Kubeflow cluster, and you'll be given a URL where you can just log in with the Kubeflow, the Civo credentials, not Kubeflow credentials, and you'll be able to see the Kubeflow UI. Nothing fancy that you have to do. We have abstracted away all the details which are there so that you can just get working with your machine learning models. So this is the Kubeflow dashboard which is there, and right now I'm in the inferencing. So what this is, I have created so this is the not the inference, sorry, K-serve, because the serving it is. So you can see the regular YAML manifest which is there. So it is creating the diffusion model which is there and using one of the images that I have created with respect to the current application, and then it will be serving that. So if you see here, it is ready. It has a URL that you can use in the Jupyter notebooks that we'll be creating, that is already created, but you'll be creating in your case, and then run it. So the app is pretty simple, and Hugging Face is pretty cool. So you can just go to Hugging Face and try out different models which are there. So in this, we are using one of the models, which is Runway ML Stable Diffusion v1.5. and getting the output. So here, very simple, you get the output and it's getting in the base 64 encoded form. And then this thing is interesting because we are trying to show the denoised images. So it'll be showing you the first 5 images, how it is slowly denoising the images to get a clearer output of the image, because that's how it does when you run against the machine learning model. And let's see if there is any file else that we want to show. Yeah, I can just quickly show you that as well. Simple Docker file, yeah, copying it. And then is the inference. So inferencing we can directly see here. So you have your diffusion model that I have created already. And you have your Jupyter notebook created, and in this you are just importing, and this is the thing which is actually calling the model. So you created your K-serve inferencing. So what are you trying to create here is you are trying to create a serverless kind of thing for your particular models, so that you should be able to directly call it and put your text as the input, or whatever input it is, prompt as an input, and it runs against the model and gives you the output. So in this particular case, it's cat with goggles chilling on the beach, and it then we have, obviously it's base 64 encoded, so we have to decode it and we have to show it. So you can see how slowly the noise are getting, denoise is happening. So it's a fully noised image, and slowly and slowly and slowly. So if I display all the till the end of the output, whatever the array becomes, you will see a very clear image of this. So slowly and slowly, it will do the denoising of the image. Now, this is the unfiltered model. So you can try and test, different things. And that's one of the benefits that you get when you run the models on your own, and you can train it with your own data, and then you'll be able to even get interesting results. So this is one of the other examples. We can actually give example. It'll take some time because this is happening on the CPUs. You can attach GPUs, and you can also do it on the GPUs. GPUs will be much faster. And so let me just also zoom in a bit. So if you want not able to see, it's just simple imports and a request. And in the request, you are going to the model URL that was there, and in the predict, and then in the JSON, you are passing the prompt. So it's horse riding on Mars, and soon it should, like it's already running. You can see that it's already running over here. And you can also go to inferencing logs, and you can see it's already happening. So 2 out of 5. So once it's like 5 out of 5, because I'm doing the 5 iterations over there. So once it's 5 out of 5, it should be giving you the results, all the 5 simple images. But I know it works, and it works because that's why you have seen, right? And it's still counted as a live demo, although I have already, pressed enter. But yeah, we have 2 minutes. It'll just work. If not, then I'll show you in some time that it'll work. You can come to me. Going back. So in the end, the thing which I want to convey here is that generative AI is cool. It's awesome. You all should use it. And it's helping, but it's something which is growing a lot. It is something where companies are searching for the use cases and the implementations that they can do. I know a lot of companies are kind of having, forced thing that they have to use Gen AI and just add it into their product so that they can call it a Gen AI product. So those kind of things are there. But just a quick plug for Civo. So since we are the infrastructure company, what our main goal and the mission is, and we have our machine learning experts already in the room. So Josh is there, our machine learning intern, Rishit is there, so you can talk more to them what the vision is. But overall, we want to simplify the overall process that you are having for your machine learning workloads. So for example, Kubeflow as a service, we also working towards the sustainability goals, because the GPUs, they consume a lot of electricity. They need more data centers, more electricity. So we have a partnership with Deep Green that reuses the server heat to heat up the swimming pools. So that is something interesting, and it is in production. When you go to civo.com, you have the deep green region where you can create a GPU, and you are actually heating up a swimming pool. So in a sustainable way, you are still using this. Also, we want to simplify the process. So for example, Kubeflow is there, you can install it, but installation is the pain. It's very kind of hectic process, and as a machine learning engineer, you do not want to go through that process of that I want to install, I want to know Kubernetes. So we want to abstract everything. So in this, there's no Kubernetes that you are learning. So in this, it's simple. You just get the Kubeflow dashboard. You create your Jupyter notebooks. You have the object store. You have the persistent volume claim. So you have the data that is flowing around, and that can be shared across. You can have teams. So there are so many things integrated in the single platform. So what we encourage is go and try out Kubeflow, and then, yes, give us the feedback, because that is pretty important. And Civo is kind of pretty open to getting the feedback. So give us the feedback so that we can improve more for the use cases that you have in your mind for the AI applications that you are building. So that's pretty much it. You can try. I know it's gone. It'll take some time, but yeah, you can try the GPUs and stuff which are there on Civo. And yes, we do have GPUs available, so you can try out if you want to run any of the things. And thank you so much for the talk, attending my talk.